Hello, in this video, I want to talk about the redesign process I went through while completing my project. At the time when I had first had my idea of an intelligent adaptive website, I did not even know the commercial EEG sensors that were available to buy at the time. I did some research and I bought a sensor.
So at that time, I only had an EEG sensor and an idea. So I just did research and play around with the default applications that came with the EEG sensor. One of the applications allowed me to see my brainwaves on the computer, but it did not really relate to my project. I did not have a lot of success until I came across a Creative Commons Java program posted online. I played with it and I was able to modify the contents so that I can read the default computed brainwave values from the sensor, which are frequency, meditation, and attention values. At the time, the challenge for me was to make a system that will let the Java program communicate with the website. I thought about making a temporary database file that can hold the data while the Java program can write to it and the JavaScript on the website can read it. I used the JavaScript object notation parse function to read the temporary file on the website, and I used the file writing utilities on Java to write the meditation and attention values into the file. I used the JavaScript on the website to check the database file many times a second, and now I have a website that can update itself based on the values of the temporary file. I completed the communication needs in my project, but then I was faced with another challenge, and that is to analyze the brainwave themselves. This is when I researched into artificial neural networks and found applications that would create one. I took beta, theta, alpha, delta waves valued by the EEG sensor once a second and tried to classify them into states when I'm excited and states when I'm impartial. But the neural network did not predict anything, it just outputted a constant. So at that time, I thought the data values were too random so that the network cannot detect a correlation. This fact forced me to research other ways of analyzing the EEG data. I know that the EEG sensor can output raw data at 512 times a second, but I had no program that can read that data. So I did more research online and came across an open source program developed a few years ago to collect EEG data and make program. This program connected fine with my headset and I was able to set it to record raw EEG data and write it into a CSV file. However, I still cannot analyze the data in real time by implementing a machine learning model inside my system. Through more research, I found a really popular programming and data analysis environment that the EEG sensor has SDK support for. So I downloaded the SDK and was able to record the raw data from the EEG sensor directly into large arrays. I was then able to apply a median filter to the data and also apply fast Fourier transform to the data. This is where the project page picks up, with me taking data and training various machine learning algorithms with it. I got my EEG data from watching videos that made me excited and passive. I divided data into 2-second epochs that were analyzed by FFT independently and assigned an output value of 0 to the excited waves and an output value of 1 for the impartial waves. I then fed the data into machine learning algorithms for them to classify. Most of the algorithms trained with mediocre results, but artificial neural network achieved the highest accuracy of over 77%. I implemented the artificial neural network inside my system for the adaptive website and was finally able to finish my whole system. Now my system can record, analyze, classify EEG waves, and activate changes on a website in real time.